It is very common in chemistry to want to know what percent of a substance is either a type of molecule or a specific element. For example, if you had a lake or a pool that you need to test whether it's safe to swim in, you need to make sure that the percent of certain chemicals were above a certain number, such as your chlorine in your pool has to be above a certain percent, and that the number of poisonous chemicals, maybe something like nitrates from fertilizers, were lower than a certain percent in order for it to be safe. But what does it mean to find a percent? Well, let's do a basic example. If there are 20 objects and 5 of these objects are blue, what percent are blue? And you've probably done a problem like this in math class, and all you do is you say, well, you do 5 objects divided by 20 times 100% equals 25%. But what is this formula that we're doing? Well, the general formula for a percent is part, or whatever we're interested in, divided by the total times 100%, and that's going to equal the percent. The reason why I say times 100% and not just times 100 is because you have to remember to add the percent sign at the end. So now let's keep this formula in mind as we apply it to chemistry. And in chemistry, we often want to find a percent composition. So let's start with a simple compound. Let's start with potassium chloride. And we want to find the percent by mass. Usually in chemistry we're doing percent by mass, so we measure what percent, what part of the total mass is whichever element we want. It's possible to do percent by volumes and percent by other measurements, but percent by mass is most common. So we're going to find the percent potassium in this compound. So what we first need to do is find the molar mass. And this formula, part over total times 100%, is going to just change a little bit. So the part is going to be the molar mass, mm, of the element over the molar mass of the compound times 100%. So the part is the molar mass of the element we're looking at, and the total, the whole, is the molar mass of the entire compound. So the molar mass, the part of potassium, is 39.1, and the total molar mass of potassium chloride, we have to add potassium plus chloride, so that's off to the side 39.1 plus 35.5 to give us 74.6 grams per mole. So the total mass is 74.6 times 100%, and that will equal 52.4% potassium. Let's do the same thing for the percent of chloride. So the molar mass of chloride is 35.5 divided by the total molar mass, 74.6, times 100%, and that will equal 47.6%. And the way we can check this is that all percents or the sum of all percents should add to equal 100%, because all the percents combined, so potassium and chloride are the only things that make up this compound KCl. So when we add these percentages, 52.4 plus 47.6 does equal 100, so we're good. Sometimes because of rounding it might be a little off, maybe it'll add to 99.5%. That's okay. It's just if you end up with something like 95% or 105%, you know you've done something wrong. Now let's try one more, and this time we'll find the percent composition by mass for the compound Na2O. So we'll start with sodium. So the percent sodium equals, so it's part over whole. Well, the molar mass of sodium is 23 grams per mole. But notice in this case we have 2 sodium ions in our compound. So the top of our fraction, has to take into account that there are 2 sodiums. So we have to multiply it by 2, so we end up with 46 on top. And then on the bottom we do the molar mass of the entire compound. Well, oxygen is 16, so we have 23 times 2 plus 16, and that will give us a total molar mass of 62 grams per mole. So that will go on the bottom, times 100%, and overall that equals 74.2% of the total mass. And last, we will do the same for oxygen. Oxygen total mass is 16. There's only one oxygen, so we don't have to worry about doing anything to that molar mass. Total mass of the compound is still 62 times 100%, and that will equal 25.8% for the oxygen. Again, if we add these up, 74.2 plus 25.8 does equal 100%.